Hi there, and welcome back to another lecture in BCIT's Technology Teacher Education TTED 4010 class. This is our introduction to programming, and we're going to today start talking about our Arduinos and how we can get code onto them. Now, leading up to this project, we've done let me just hide that for right now. We'll come back to the Arduino later. We've done a few different things in here. We started by taking a look at VexCode VR and used the drag and drop programming interface on here to get our little robot to move around on the screen. And that was kind of fun and interesting. And a really great introduction because you could get something up and running really quickly while developing some idea on code and loops and setting things up, and really good introduction before we head into the Arduino. And then we popped over and took a look at Scratch and created a game to play a little bit of Pong, and we were thinking about variables in there and if-then statements and controls. And Pong was a little bit different because it's just running inside the computer, so it's all virtual. We don't have any real components. And today we're actually going to take a look at hooking things up for real, and we are going to use our Arduino and install it on the computer. And I'm going to talk a little bit about that and how your computer talks to the Arduino. But before we get to that point, to keep on the virtual theme and the drag and drop and things that you can do anywhere you've got access to the internet, I want to talk about TinkerCAD. And this is just an amazing thing that Autodesk has, I guess, kind of taken over. There were other developers on TinkerCAD, and then Autodesk has come along and really done some really neat things with it. To access TinkerCAD, you are going to need an Autodesk account. So if you've got AutoCAD installed on your home computer, then you've probably got an Autodesk account. It's the same one that you're using to download educational copies of the software from Autodesk. If you don't have an Autodesk account, you can join now. But if you do have an Autodesk account, you should be able to sign in right here. And there's ways that when you're teaching, you can actually have a class of students all signed up on here. And let's see, this one, there we go. Email or username. It already knows who I am, and it logs me in right here. Oh, right, I changed my password. Thank goodness it blocks it out. Otherwise, YouTube would have a lovely posting of my Autodesk password right now. Now, a lot of people think of TinkerCAD as a site for introductory CAD, and that's really what it was originally developed to do. And so you can see in here that there's a number of simple little solid models that you can work with, and you can actually use it to design things and export them for your 3D printer. Um, Quite frankly, after using real CAD software, real parametric CAD software like Fusion 360 and Inventor, um, and even online packages like Onshape, I get what they're trying to do with keeping the CAD package simple and easy to use, but what I find is it's simple and difficult to accomplish what I want because I'm used to doing maybe more complex things in the other packages. So anyway, not to take it away, they've put a lot of effort into this, and I've seen really people do really neat stuff. A great way to introduce simple shapes and thinking about objects to grade 8 and 9 students maybe, but man, does it get frustrating after a little while. Where they've knocked it out of the park, in my opinion, and being a bit biased towards electronics and coding and all that, is their circuits section right here. Okay, so once you've logged in and you'll see something like this on AutoCAD, come to their circuits section. And you won't see all these circuits down here just yet because you haven't created any of them yet or had anyone share them with you. But let's just come in and create a new circuit and see some of the things that you can do on here, because this is not just a great Arduino simulator, this is a great electronics and breadboarding simulator. And oh, look at that, they've updated it now. The new microbit, new type of controller, the BBC microbit coming along. Very cool. They've got Arduinos in here, they've got breadboards in here. Just a few things about the user interface. Your login, log out is all right up there. There's more stuff along. It will create some weird and random name for your project. You can rename that if you want to save it as something sensible. And there's a few simple tools along the top right here that we'll get to taking a look at a little bit later. In here, you've got a list of components. So this is like your parts bucket and where you can draw things out. And it starts out with it being basic. And if you go to all, you get everything in here. So all of those components that we learned about in first semester are resistors, capacitors, polarized capacitors, our aluminum electrolytic capacitors right there. We've got diodes, Zener diodes that we didn't talk about very much, and inductors that we'll talk more about in third semester. We've got push button switches, potentiometers, variable resistors, switches, photoresistors, all sorts of neat sensors, ultrasonic distance sensors, keypads. I've got a little kit for you that's going to have physical versions of all of these, but you're actually able to log on to the internet anywhere and start experimenting with them. Neopixels. So cool. If you want to see one of my applications for Neopixels, just when you're done all this or in a separate window, pause this and Google Blinky Fish Head. And you should find a video of the Blinky Fish Head on my DT Engineering YouTube channel, which you're watching right now. Okay, so Neopixels, very cool thing. Neopixel is a brand name applied to them by Adafruit, who is an online vendor who really started popularizing them. I refer to them more generically as a WS2812B LED, and we will be talking more about them and why they're so cool later on in the course. They've got motors and motors with encoders, which we'll be talking about, and you'll be doing real encoders and real motors later on in the course, and you'll be able to take a look at them here in TinkerCAD. 16 by 2 LCD screen. You've already got one of those on your big bad breadboard board, and you've probably been looking at it for a while saying, when are we going to figure out how this thing works and why I bolted it in there 4 months ago? Um, different batteries. We're not going to use the lemon battery or the potato battery necessarily, but it's nice that you can simulate that. We've got breadboards on here. And so this is the first thing after we just go down. I just want to show you a few things that you can do on here that's really cool. Drag your breadboard out onto the board right here. And there you go. And look at that. You've got a breadboard. And you can come in here. And as you put your mouse across it, we're just going to call the breadboard 1 right there. Actually, we'll just leave that right there for now. You can see when you put your mouse over top of this rail on the breadboard, it highlights that whole rail to indicate that they're all connected together. Okay, and when you click over any of these 5, you can see it indicates that these are all connected together right in here. So if I plug in right here and I plug in right here, those 2 parts are joined. And we use breadboards a lot in first semester and perf boards, and you're still going to be using them. They're great tools. There's also an Arduino Uno down here, and you can just drag the Arduino onto your board right here. And, on our big bad breadboard board, it kind of sits down in this corner, and you can zoom in and zoom out with your center mouse button, and you can click and drag things around so that you can position them on the screen so you can see them really easily. And when it comes time to putting wires onto the board, that also goes pretty easy too. So one of the first things that we're going to do is we're going to wire this up by taking some power from our Arduino, and we're going to take a ground wire, and we're just going to run it. Oh, let's run it. Let's put it on the negative side. Good idea you see we've got that little negative right in there, and click right there. Now, as our ancient rules of breadboarding passed down by the earliest breadboarders of the Renaissance, the electronics Renaissance, for some reason we have chosen that our ground will be black. So make your ground wire into a black wire right there. Now, if you want to curve it a little bit more nicely, you can come in here and you can double click on it. That gives you a joint right there, and you can actually fold that, and look at how nicely you can wire that in right there. And there is a ground wire, and that connects our Arduino right here to ground all the way along right here. So that's an important part of your component. Of course, if we're going to connect ground to something, we should also take our 5-volt line over here. Okay, and you can see your Arduino's pins are all labeled in here. And we're going to take our 5-volt line, and we're just going to double click or single click on that and hold. and bring it up here to the red positive. And since we're plugging into the red line, and we'll make that red, then you can double click on there and you can route that in. You don't have to get all this fancy tucking that in right there, but give it a nice routing in here. I usually route mine around the capacitors like this when I'm doing it for real, so why not do it in here? There we go. And now what I've got is I've got power and ground running to the circuit. Okay, now I've only got power and ground on this side of the breadboard. So as you'll recall, what we do have to do to get power over to this side of the breadboard is we have to put another wire in here. And you can do it down at this end of the board if you want, because we've already got a couple things plugged in there. Follow that red line all the way along down right here and jump it over to the red side right there. And make sure you tell it that you want that to be red. Then get it out of the way in case you want to use that part of the breadboard a little bit later on. Now, when you're doing this for real, you want to keep this all nice and flush to the board, neat and tidy, and that sort of thing. Let's add a black wire in right here. Need to double click a bit harder. There we go. And it started a new wire for me. If that happens and it starts a new wire, just hit the escape key. There we go. And I guess those two wires have to cross at some point. Now, at this point right now, we've got power running to the board. And if you want, you can actually save that file. And it says right here, all changes saved. So it's automatically updating. And there you go. It's waiting on your system. So next time you log in, you'll see that setup available. We're going to do a few more things to it, though. We're going to bring a resistor in here. And you can drag that resistor right over to here. And let's put the resistor. You can use the resistor to jump from right here down to ground. Okay. And you'll see that when the resistor comes in here, it asks you what resistance do you want it to be. And it's got K ohms and ohms on it. We're going to set that down to ohms, and we're going to make it about a 280 ohm resistor. The actual value doesn't matter so much. We're just doing it so that the LED doesn't get too bright. Now, what's really cool that you may not have noticed is that when I changed it to 280 ohms, look at that resistor color code right on there. Red for 2, gray for 8, brown for 1, 0 after the 2 and the 8. So the software's got some really cool stuff built in there as we come along. Let's grab another resistor and drop it in just right over here. And notice I'm getting this end to go to the ground line right here, so that if I put electricity in this end, that's going to come back along the board here, down through here, over to this side, and back to ground. I'm using my Arduino as my 5-volt power supply. Remember to set that one also to 280, not K ohms, ohms. There we go. We've got 2 resistors in there. And let's put some LEDs in here. So you might have to scroll around to look and find your LEDs. Bring your LED in right here. And now, it's hard for them to make the legs exactly the way I want the LED to be, because I usually, on my board, I jump the LED from this side over that side just by bending the legs. And you can fake it a little bit in here, but what I'm going to do is I'm just going to put it right in here. Now, keep in mind that that is the wrong way around. Okay, do you see why I did that wrong? Okay, well, I did it wrong because I made a mistake. But do you see what the mistake was? The mistake in there is that there is a flat side on that LED. And remember that the flat side of the LED is the cathode and should always be pointed towards ground. So I'm just going to move that over there. And now you see I put my mouse over top of it. It says cathode, and that's going to flow through the resistor down to ground. And there's my anode that I'm going to hook up to my positive power supply. Let's bring another LED in right here and hook it up right the first time. There we go. Now you can change the colors of the LED as you put them in. Let's put an orange LED in there or a gray LED. And in the bag I gave you of parts at the beginning of the year, you should have some spare resistors. Like I said, it doesn't matter if they're exactly 280. You could put 100 ohm in there. You could probably get away with 50 ohm. In fact, given the Arduino, I happen to know that you don't really need a resistor. You could put a wire in there. But anywhere up to, well, even a 1K ohm would work in there. Just your LED would be a little bit more dim because the higher resistance would restrict the amount of current flowing through the LED. Okay, well, that's looking pretty good so far. We've got all those wired up. Now, I'm not even going to tie the Arduino into it right now. Let's just take a positive wire right here and run some current into here and see if the LEDs turn on for us. Now, since that is plugged into the red line, I'm going to make sure it's red. And since this one is plugged into the red line, I'm going to make sure that's red. When you're breadboarding in my class, black and red are special colors, okay? Do not use them for anything other than ground and power. Now, nothing fancy is happening here. Click on Start Simulation. And look at that. Did you see the little USB cable plug into your Arduino right there? When you plug the USB cable into the Arduino, your computer supplies 5 volts over USB to your Arduino, and the Arduino turns on. And it provides 5 volts into the board right here, comes through this wire, and turns your LED on. It's, that's not too fancy, but hey, it's working. Now, to get out of that and make changes, you have to stop the simulation. Oh, look at that, our simulation time. The simulation runs a little bit slower than the real world sometimes. So it is emulating everything online, and it's got a lot of calculating and figuring out to do. Oh, don't move the Arduino. I liked where it was. Okay, move the view so people can see. I'm gonna point one other thing out. If you look at your Arduino and you've got a brand new Arduino that's never had any code on it before, you've got some little lights that will light up on here. And now, depending on who manufactured your Arduino and where it was made, you're going to see different lights come on at different times, but you might have a power light down there, and you might have one labeled L that's blinking, and that's the built-in LED that's hooked into pin 13. And so pin 13, you can use it to do a whole bunch of things, but it's also controlling a little LED right on the board. So you can actually test some things on your Arduino without hooking it up to anything else because you can make that one LED blink. So pin 13, just a little bit special in there. Okay, I'm going to stop that simulation right here. It's okay if your LED isn't blinking right now. That just means there's different code or no code on your Arduino, and we're going to take care of putting code on your Arduino before we're done here today. Alrighty, so were you able to get those LEDs to light up in TinkerCAD? It's a good start. Now what we want to do is we want to put some code on them, and we want to use the Arduino to control them. Yes, you're sitting there going, damn it, he's making us build a Winky Blink again. But this is a software-enabled Winky Blink, and you'll be able, okay, it's a Winky Blink. So let's go ahead, we're just going to delete this. This is like the ultimate version of Winky Blink, because you can program it to blink however you want, bringing truth to my saying that if you can blink an LED, you can rule the world. So I'm going to come in here, and you can see I've got digital pins on the Arduino, and it says right here, digital PW, and some of them are PWM pins, which we'll talk more about later on. Right now, we're just going to turn them on and off, but PWM allows you to turn them on partway. Which is a really neat thing, and we'll talk about how they do it. 0 and 1 are used for uploading and downloading code to your computer. We can talk more about them later. They're kind of special pins, but we're just going to use, let's use pin 9 and pin 10. And this time, because I'm not hooking that line into +5 or ground, I'm going to leave that one green, and then I'm going to run right over to here, and let's make that one orange. Okay, there we go. So I've got 2 wires, and I use different colors for each of them because later on when you start building up more complex circuits on your board, it's sure nice to be able to say, okay, where does the green wire go, and not have to sort it out from 15 different other wires all the same color. And we'll talk a little bit about keeping your breadboards neat and tidy again when we start wiring up your breadboard. There we go. We've got this hooked up, and now what's going to happen is we can control whether pin D9 and D10 are turned on. So you remember that that LED was blinking in our simulation? Well, that's because there's some code on your virtual Arduino already. So let's take a look at what that code is by clicking on the code button right up here at the top. And a little window pops out right in here. There's those drag and drop things again. And if those drag and drop things are working for you, that's a big shout out to a team, what they call it, the Eternal Kindergarten Group or something at MIT. And it's a bunch of people who are amazing computer geniuses in their own right, but who love sharing that joy with young people and have put their computer genius to work trying to figure out how to help young people and less young people learn computing more easily. And we're going to use that, and we're actually going to use that. So today we're going to transition into the text-based semicolon and squiggly bracket world of actual C programming. But let's take a look at what it does right now. And there's your code right in there. So it says set built-in LED to high. Now keep in mind the built-in LED is this one right down here, the L button right here, or the L LED on your board that was probably blinking, and that's actually tied into digital pin 13. So it's got a predefined number in here. We could also say set pin 13 to high and the same thing would happen. Wait for 1 second and then set it low. Okay, now we'd like to light up our LEDs. So what I'm going to do is I'm going to set pin and drop it in right here. And I'm going to set pin number 9 to high. There we go. And that will turn it on. But if I want it to turn off, you also have to tell the computer to turn it off because the Arduino will do exactly what you tell it to do, which is often distinctly and frustratingly different from what you want it to do. So let's come in here and we'll drag that in right there and we'll set that pin to low. And let's just take a look. We're going to click Start Simulation right now. And simulator time, 1 second. Oh, can you see what I did wrong in there? I'll pretend I did it intentionally. This is one of the things, actually, I'm going to stop simulation right here. When you're throwing code together and you're experimenting with it, don't be too worried if you make a mistake the first time around. I've been using the Arduino with students and the PIC microcontroller before that for 20 some odd years now. I have yet to see a student who has managed to blow up a circuit or damage anything by the code they have loaded onto their Arduino. I've seen them blow things up by plugging them into the wrong sockets, and I've seen them destroy their Arduino by connecting them up to the wrong power supply and the wrong voltage. And there's all sorts of physical things that you can do, but when you're playing around with code, particularly virtual code right here on a computer screen, you can't screw up. So go ahead and play it. If it doesn't work, just come in here and change the pin number and say, right, that's supposed to be pin 9 that goes low because I set pin 9 high, so it wasn't turning off. So it was turning pin 0 off, which didn't do a heck of a lot for me. Let's start that simulation again. And there we have one LED blinking, and that's controlled by pin 9 right here, turning high and turning low. Now, in just a moment, I'm going to show you how to get the red one blinking. And of course, because we're making a virtual Winky Blink, we're going to blink the yellow one, then the red one back and forth. So they're going to alternate. Press pause, drag and drop a few blocks on there. Actually, don't press pause just yet. You didn't press pause? Okay. Drag and drop a few blocks onto there and see if you can make that red one blink. I'll give you the answer in just a second. I said to press pause. You did press pause, right? Good. Okay, so it's going to be exactly the same as we did before, but this time we're going to set pin 8. Notice it stopped the simulation for us immediately as we did it. We're going to start it out low, and then we're going to set pin 8 to high right down here. Okay, and now when you start the simulation, it's not blinking. What could be wrong? Oh, did I choose the wrong pin? Oh yeah, my notes down here that I'm following said I was going to use pin 8, but at the last minute I decided to use pin 10. See, it's still not a crisis. You stop the simulation, you come in here, and you just change the pin number. There we go. It's a winky blink with exact 1 second timing. Only costs about 100 times more than making one with transistors and capacitors. Um, However, the capabilities are awesome because now you've got all these pins on here. You can have a 14-pin winky blink. And when you start to figure out how you're really doing it, you can have thousands of pins or thousands of LEDs blinking under your control if you want them to. And you can have them be interactive, so they will only blink when the sun is out or when it's dark or well, anyway, we'll get into all that going on. So how's that looking to you? LEDs blinking. The Arduino-based Winky Blink. Now what we want to do is we want to translate that into the real world on your physical Arduino. Now I have to say your physical Arduino doesn't understand all these blocks, but there's something really neat that goes on in here. And we're in block coding right now, but we can change this over to text-based coding. And let me just remember where this went. Uh, let's see. You can download that code. We will come back and do that. I'm just looking for our little button here that changes us from blocks. Oh, I need to stop the simulation. That's it. Stop the simulation, and under blocks, come down here and tell it that we want blocks plus text. Okay, so that opens your screen up a little bit more. And right over here, you see what the Arduino code actually looks like. And so the blocks have hidden a little bit of the complexity from you, and the blocks are a great fun way to get started in this and try some things out. But if you want to do the more complex stuff on the Arduino, you are going to have to get used to actually using the physical code. And what you'll see up at the top is it gives us um, uh, two main parts of our program. And void loop is a really important part of the program. Now, it took me a long time in programming to understand what void meant. And I don't know why, it just seemed one of those weird things that you just type it in and it doesn't really mean anything. And what I'll say is, you remember a while back when we were doing the VexCode VR, we were writing subroutines and we were sending data to the subroutine. Well, you can also write subroutines that send data back, or functions, as they're sometimes known, that will send data back. And if the function is sending data back, it needs to know to expect that data coming back. If there's no data coming back, you tell it that this function will not return data by putting void into the word. Okay, so when you see void, it just means this function's going to run and it's going to do things, but it's not going to return any data to any other function in your program. Okay, you don't have to remember that. You can just say, I type in void for some weird reason. It worked for me for years. Void function name. Okay, why do we have two brackets after it? Okay, that's because we're not passing any data to it. If we had a function that we were passing data to, just like you passed some coordinates and some information to your circle drawing routine in VexCode VR, you passed the radius data over to it, we'd tell it what type of data to expect in between these brackets right here. The key part that you need to know is that this routine is called loop. And yes, it has to have void in front of it. And yes, it has to have bracket, bracket, specifically round brackets after it. Okay. But just like void setup is up here, Same thing applies. This is a function. It's going to run once at the beginning of your program, and we're not passing data to it, and we're not getting data back from it. So after you see that void set up in there, the first thing you'll see is the squiggly bracket or ellipses. And on my keyboard, these are just above the enter key, and you have to hit shift to enter them. Now, you'll remember when you brought a forever loop or something like that in your code right here. And let's actually take a look at that right now. And I'll show you what those squiggly brackets do. They're like a big hug around things. So here we go, control. So if I wanted to repeat something 10 times in here, drag that in right there. Okay, and I can put something in right here. Now this is down outside the part of the code, and we're not repeating anything right now, but I just want to show you right on there. See that opening bracket and that closing bracket, the squiggly brackets right there? That is like this part of the repeat and this part of the repeat. And this code right in here is what's telling it to count from 0 to 10 and increase the counter each time. So that's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but we'll worry about 4 statements later. Get rid of that right now. Okay, I just want to show you the brackets. Think of them as a big hug around that code. So, and again, it's important that the squiggly brackets, the ellipses, that this and this are the hug that's holding all this together in the setup routine. And down here, we've got squiggly bracket right here and squiggly bracket right here, and those are holding these all together in the loop routine. And the loop routine, as you might guess from the name, is our forever loop. So what's going to happen is setup is going to run once, and then the loop routine is like that forever that we had for our VexCode VR. This is just going to keep going around and around till you unplug the Arduino. So this is what the Arduino code actually looks like, and it's a direct translation from the code right on here. So if you're trying to solve a problem on your Arduino and you really like drag and drop, you can come into TinkerCAD. Sit down the computer, you don't need your Arduino, you don't need a power supply, you don't need any of that, and you can hook up your breadboard the same way that you're going to hook up your physical breadboard, and you can actually test out all the code on the computer, and you can drag and drop things, and it will generate this text-based code for you. And you can actually take a look at that and find out how things like inputs and math statements will look when you write them out over here. So it's a great comparison and a great way to get introduced to how this code comes together. Like I say, later on, we're going to be doing more complex coding. And as you get more comfortable with it, the text-based interface will be a lot easier to use. Okay, but for now, this looks really friendly, really easy to do. Oh, look at that. I just dragged that and a little gap goes in right there. Things space apart. If I change this, to high right in there, it changes the word right in there to high, low. So you can come in and you can play around. It's a one-way edit right now. I don't think you can come in here and start typing in here. Yeah, you can't change that because just the way it encodes it all. You might enter typos and errors in there. Notice also that we've got some words that are all caps, okay? That's not because somebody's tweeting them. It's because the computer recognizes the difference between capital letters and lowercase letters, and some of the commands have a capital right in the middle of them, presumably to make it easier to read. Once you get used to doing it, once you've done it 1,000 times, Digital Write always has a cap in the middle of it. But the computer does care about all these little things. And these semicolons, the semicolons tell the computer that's the end of the line. Okay, the end of the command. When it sees a semicolon, it says, that's it, I'm going on to the next command and going to execute the next command. Okay, so there we go. We've got code running virtually, but now we want to get it running for real. So what can you do right now? Well, one thing that you can do is you can highlight and copy and paste that code into your Arduino IDE, which I'll talk about in just a moment. Or what you can do is you can just download that code right there and it will save the file, and yours probably won't open up with the Arduino IDE as default because you probably don't have the Arduino IDE installed. What am I talking about when I talk about the Arduino IDE? So let's turn on um, this window right here. There's my Arduino. And then let me grab my Arduino IDE and drag it over to this screen right here, and bang, there we go. So now I have an Arduino right here, and I have an Arduino IDE, or Integrated Development Environment, right there. Well, where did that Arduino IDE come from? Because it would be really useful if you had an Arduino IDE to use. Let me just shrink it down and put it right behind me for a moment, and I'll switch over right here. And this is the Arduino website, and I will shrink that down a little bit so it looks better on the screen right here. There we go. All right, so the Arduino IDE can be downloaded from arduino.cc. Okay, if you ever forget that .cc part and you're going to org and com and all that, you can't find it, just tap Arduino into Google. It will almost invariably bring you to here. So Arduino is kind of a neat project. It derives the name from a bar in Italy. So you can actually go online and you can Google, I've Google Street Mapped the Arduino bar, where this must be about 20 years ago, a couple of engineering students were sitting down and saying, hey, you know, these microcontrollers are kind of a thing, but they're kind of hard to use. Our artist friends keep hassling us with questions about how they can make different lights come on and different things happen and motors be controlled. Wouldn't it be nice if we could hook things up so that they had an easy way to program a microcontroller? And to an engineer, squiggly brackets and semicolons seems easy. Well, we'll just simplify the semicolons and squiggly brackets, but we'll keep it looking like C because we like to keep our secret engineering code in there. Well, it wasn't what they were thinking necessarily, but it sometimes feels like that when you're learning it. All right, so let's get going with this. You've already done this part where you've bought an Arduino, but you'll see that there's many, many different types of Arduino out there. We're using the one called the Arduino Uno R3, but you can get an Arduino Mega, and you can see all the extra pins on there. It's about twice the size of your Arduino. Somewhere in here, I've got an Arduino Nano. I don't know, I've got a big bag of microcontrollers in here that I've been experimenting with. Not all of them are Arduinos, and somewhere in there, there's an Arduino Nano, which, as you'd guess, is smaller. And then there's all sorts of different things that you can program using the Arduino interface. And you're also going to need your USB connector right here. This is the same as you might plug into a printer or any of your peripherals, and you can tell it's the right one because it fits into your Arduino. If you bought a different brand of Arduino, you might have a different connector right here. You might also have an Arduino that looks something like this. This is actually an authentic made in Italy brand name $30 Arduino with a replaceable dip at Mega chip on it right here. If we blow the chip up, we can pull it out and replace it with another chip. This is a $5 board with a surface mount soldered chip that's the exact same chip, just packed into a different package on here. There's also a couple differences that I'll talk about later on. This one is using a CH340 chip to do the USB to Arduino communications, and this one is actually using a actually another Atmega microcontroller chip to do the communications between the USB and the microcontroller. It's a trivial difference, but I'll mention it right now because we'll come back to it. Anyway, on the Arduino IDE site, so you should have that open, and you'll want to go to the downloads page. Now, I do encourage you to explore a whole bunch of stuff that they have on here. They have great tutorials. So if you're having problems installing things, come to the tutorials and look up Getting Started and instructions for our board. You are using the Uno, okay? And they actually have a web IDE, so if you run into problems installing software or you're doing this in a computer lab at school, you can run it over a web IDE. I really recommend using the desktop, okay? And go to the Getting Started page right there. Oh, and instructions for Shield, instructions for retired boards, retired shields, code on the web, install the Arduino desktop IDE, pick your operating system in right here, and it will give you detailed step-by-step instructions. Okay, so uh, that was, where were we right here? Arduino.cc/en for English / capital G for guide, capital guide right in there. And go down a little bit further down to the bottom, and we'll skip past the online option. It's there, you can use it, but choose your operating system and you'll find information on there. For learning the Arduino, you'll find a whole swack of additional references and resources online. This is one of the reasons why I use the Arduino microcontroller. Like I say, I was experimenting with a whole bunch of chips. This is a SAM32 chip. It's actually less expensive and much more powerful than the Arduino, but the software support is nowhere near what there is out there for educational uses. The Arduino is fabulous for education because it is so well supported and there's so much documentation built up around it over the last 30 years, 20 years, I guess. Um, so you can take a look on there, and they actually have a whole section on using Arduinos in education and how to look after your board. But anyways, what you want to do is you want to follow those instructions, and we can go through here, follow these instructions. Oh, that was the web editor. You can install the web editor too if you want. But I will be making reference to the Arduino IDE as installed on your computer. Okay, so right down here, Windows, Mac, go ahead and choose that. And follow these instructions right down here. You can press pause while you go to do that. But basically, you should see it installed on your computer. And when you're all done, you should have something like this window pop up right here. There we go. Now, I just noticed I've got to change a few settings. Yours is going to look a little different from mine when it pops up. There's some important stuff that shows up in the bottom corner right here, telling you what type of controller you're using. And I've actually been working on something called an ESP32 cam, which I was able to program using the Arduino IDE, but it's an entirely different microcontroller. In fact, Arduinos have become so popular that even other microcontroller developers are making their chips to work with the Arduino IDE. I keep saying IDE like it's some sort of term that people are expected to understand. It stands for Integrated Development Environment. And what it means is that you're able to write your code in here, and then you're able to compile your code, which takes what you write and turns it into a set of instructions that the microcontroller can understand, and it will upload it to the microcontroller. So it takes three different processes and integrates them into one development environment. So when you hear the term IDE, it just means that you don't have to write your code in a text editor, compile it with a compiler, and then upload it with an uploader. It's all integrated into one to make life easy, and it's pretty standard for most microcontrollers nowadays. 30 years ago, it didn't used to be, so they gave it a three-letter acronym to describe it when somebody finally said, hey, why don't we take these three different tasks and put them all together? Alrighty, now that code from the website we were just, oh, before I get to that, I should show you. How do you know if things are hooked up and running properly? Well, first of all, okay, if you've got your Arduino software installed and you're looking at that screen, take your little USB plug, plug it into your computer, plug it into your Arduino right here, and you should hear a little ding ding sign indicating that something is connected to the USB for your computer, and you should see little lights come on your Arduino board. One of them may start to flash. Mine doesn't have the blink code on it, so it's not flashing, but that's okay. All right, so now that that's set up on there, I want you to do a very important check. Come down to the bottom corner of your window, the start screen right on here, and right click. Now in Macintosh, it's going to be different, but hey, Macintosh is easy to use. You've probably well past this point already. They're so easy to use. Um, Sorry, I'm a jerk to my Macintosh users. OS discrimination is allowed. So let's see, Device Manager. Um, so we'll come in here and we'll pull up the Device Manager. And your Device Manager is a really neat thing that tells you all the different stuff that's connected to your computer. And this can be useful when you're hooking up any kind of hardware peripheral to your system. And somewhere in there, you will find that you have something that says ports, COM and LPT. LPT is the old line printer ports that date back to the DOS days. And the COM ports are a way of giving addresses to various types of serial data communications. Serial means we're sending one bit of data after the other. The old line printer ports, the LPTs, they were a parallel port that would send 8 bits at a time, which isn't nearly as good as you'd think it would be. So anyway, here we've got a standard COM port, and usually your computer will have at least one serial COM port going. Depending what you've got plugged in, you might have more. And here you'll see it says, for me, it says USB serial CH340 on COM3. So when I talk about COM3 or COM4 or maybe COM27, depending what you plug into your computer, that is the COM port, the address that Windows is assigned to have your computer talk to your external device, in this case an Arduino. Now, if you're not 100% sure that's the right thing, come over to your Arduino, and while you're watching that COM port screen, unplug your Arduino. And it will flash back up on here. And now, under ports, COM, and LPT, you'll see that it disappeared. Depending on your type of board, you may need to install a CH340 driver. I believe the latest versions of the Arduino IDE come with the CH340 driver installed, so I'm not going to talk about that right now, but if you've got one of the non-brand name Arduinos, you may have to Google Arduino CH340 driver. I can provide additional links to that and assistance if you're running into that problem. If you have the brand name Arduino and you plug it in, it's really fancy. Watch this. Instead of getting the generic CH340 driver, oh, look, blinkage. My LED is blinking on there. It pops up right on here. And where are we right in here? Ports, common LPT. It actually shows up as an Arduino Uno, but you'll notice this one talks on COM4. And that's just so if I had them both plugged in at the same time and I wanted to program one, I could say, do I want to program the one on COM3 or the one on COM4? Let's plug that back in. There we go. The Arduino's up and running. Now, it's possible that you may be running into hardware issues that are keeping your Arduino from getting up and running. For instance, if the wiring on your big bad breadboard board has a short circuit in it, you'll get and it'll plug in and it will shut down right away. And you may need to unplug and go back and sort things out. And in some cases, you may even need to restart your computer in order to reset the serial port. Anyway, an important thing to know when you're using a computer and you want to find out what COM port you're attached to, Windows has it stashed in the device manager and Macintosh has it stashed somewhere equally easy to find, I'm sure. Okay, I'll go easy on the Mac users. Here we go. We've got our Arduino hooked up in here, and we've got our IDE. And now the next thing you have to do is you have to check and make sure that you have the right computers or the right microcontrollers selected. Now yours is probably defaulted to Arduino Uno. So under Tools, you'll come in and hopefully it says Arduino Uno. And I just have to come down here and find where my Arduino Uno is. And I need to switch it to Arduino Genuino Uno. Believe it or not, I won't even get into the whole Arduino Genuino thing, but you can Google it. It was a licensing trademark, schmozzle. Um, and the other thing I'll do is I'll check to make sure I'm on the right COM port. So now it says Arduino Uno on COM3. Okay, and that should be reflected right down in the bottom corner of the screen. Arduino Genuino Uno on COM3 is what you should be hooked up with. All right, now what we're going to do is we've got code right in here, and we're going to run a test. Before we do anything else with our Arduino, you can see right here our code is going to do nothing. The Arduino has a ton of really useful examples that come with it. So go to File and Examples, and in your example settings, come to Basics, and there's one called Blink in there. And you'll recall that there was a blinking of the internal LED on our TinkerCAD Arduino. This is that same code right on here. It's already baked into your Arduino. A new window should pop up, and you'll see that it's got comment codes in here, which are really useful. The comments tell you what it's going to do. And I think these guys spend more time talking about turning an LED on and off than even I would. And then your code comes in right down here. You'll notice that all the comments are grayed out. Well, they're not grayed out, you can edit them. But the computer completely ignores that. The comments are purely for humans to read. And so when it compiles your code and turns it into instructions for the computer, it leaves all that out of there because it doesn't mean anything to the computer. It just means stuff to you. And it's got a link right in here that will guide you to a tutorial that will walk you through what I'm doing. So you've got backup in case I screw up along through here. You'll notice that it talks a little bit about what's going on. So here's our setup function. It runs once when the Arduino boots up, and it comes in here. And just as with our VexCode VR, we had to do some initialization stuff. We have to tell it that the LED pin, which in the case of this Arduino is pin 13, is going to be an output, because you can use pins as outputs to control things or inputs to read things. Okay, and then we're going to come down here and you've got digital write. So that was the command that turned the LED on. So we've set it to be an output in our setup, and then as we loop this part over and over, it's going to come in here, it's going to turn it on, it's going to wait 1000 milliseconds. Okay, so the delay command works in milliseconds. So you'll see this command says wait for a second, but the number says 1000. Well, that's 1000 thousandths of a second. That's why that's in there. Digital write, LED built in, comma low, turns it low, delay 1000. And because we shouldn't have touched anything or edited anything, down here it says Arduino Genuino Uno on COM3 or maybe COM27 or whatever the device manager told you your COM port was. And then you're going to click on Upload. And when that happens over here, you should see a little bit of, just a minute, things are going on right here. Our code is compiling right down here, so you should see this little green bar go along. You should see some text pop here, some blinking just happened right over there. Those were the serial transmit and receive. And there we go. There we have our built-in LED blinking on my Arduino. Now, if you want it to blink faster, you can change this number right in here. Instead of 100, let's set it down. Well, I want something that my camera will be fast enough to pick up. So you can change that down to 500 milliseconds, which is half a second. And you can put it on there. You'll see the whole thing. It compiles the sketch. The little green bar comes along. It uploads it, lights flash. And now it's blinking faster. All right, So we had code that was going to light up our LEDs right over here. Let's go ahead and take that code from the TinkerCAD website and copy and paste it in here. Now, let's not disrupt their code. Let's go new, okay, and then we'll delete all the code that exists in there right now. So it's a blank program. Come back to your TinkerCAD window, um, and where is TinkerCAD? Circuit design. Here we go. This is the code that we've prepared and tested in TinkerCAD. You can either download it directly or highlight it all, right click, copy, minimize that window, come into your Arduino window where you cleared everything out, and paste it right in. Now, that exact same code that you prepared for the virtual Arduino in the virtual world of TinkerCAD, you're going to click on this little arrow right here, and you're going to upload it. Now, you will get a message saying, hey, save me, because this is new code on here. You can just use the default file name for now. Later on, you can save it with a file name you want. You can even click cancel if you want, but click on save. Compiles your sketch. Moves it over to your Arduino Uno. And now I have, darn it, one green light blinking. Okay, now you'll notice that I did a little bit of work on my breadboard before getting started right in here, and it's the exact same wiring that we talked about in TinkerCAD. So I've got a black wire coming from right here into my ground line that runs right along here. You will probably have to remove a lot of other circuitry from your system just to be sure that you're only looking at your Arduino code. I know you've probably got some projects from last semester still plugged in there, but so long as you unplug them from power and ground, you should be fine if we're not using those spaces for anything else. So we've got black coming over to here and black on that side. I've got red coming from my 5-volt line right down here, looped around. It sneaks through there. It's not plugged into anything. It comes and plugs in right here. I've got a red and a black cable coming over to this side. I've got some resistors right in here. I think, what value resistor do I have in there? That's red, red, brown. So those are 220 ohm resistors. Like I say, 220 ohms, 280 ohms, 560 ohms. They're all going to work for what we're doing right now. We're just keeping the LEDs from getting too bright. And you'll notice that my green one's working, but the red one's not. Well, if I follow these lines back here, I plugged one into pin 9 and one into pin 8, but my code said they were supposed to be plugged in to 10 and 10 and 9. So I'm just looking somewhere. I've got needle nose pliers around. I find needle nose pliers make it a little nicer to move the wires when they're in tight, but I can just do that. I can even do it while it's running, so long as I don't short anything out. And there we go. Winky blink. Oh, winky blink with the bonus that we've got this one coming in here. Now you can go in here and you can change your delay statements and you can make things blink really fast. Uploads the code. Blip. There we go. Really fast winky blink. And that's about as far as we're going to go today. I'm going to give you some time now to go ahead and hook that up. If you want to do something a little bit fancier, try hooking up 3 LEDs or 4 LEDs. You've got them in the parts bag that I gave you last semester. And can you make them blink all in a sequence, one after the other? Can you have them do the old Cylon eyeball where it blinks in one direction and then blinks back in the other? You can do a lot of neat things blinking LEDs with your Arduino, and you can get off to a neat start in your programming. Later on, we're going to be doing more complex things with the Arduinos. You can see right in here, I've got wires all set up for a future lesson. I don't know if it'll be our next one, But I've got a header strip right here, a potentiometer right here, and some neatly color-coded wires tucked away under the board that come out right here, and use these digital pins so that I can use the Arduino to get a display showing on my LCD display right here. A great way to have feedback from what's going on your Arduino. But for today, if you've got blinking LEDs, you have conquered the challenge. Well done. Alrighty then, I'm going to sign off right here. I'm recording this on a beautiful sunny afternoon. By the time you're watching this, who knows, it'll be snowy and cold or something out there, but that's the beauty of time shifting. I am going to stop recording right now and go enjoy a bit of sunshine.